Good morning. It is Saturday around 10. I want to make this video so you have extra time to learn about concepts regarding matrices in MATLAB, so you can get a head start before I teach it on Monday and Tuesday. So we discussed, again, I want to make sure I'm on the right screen because this gets weird on my computer sometimes. Yeah, that's okay. So the last time we talked about the concept of a matrix, and we know that a matrix is defined by rows and columns. So if I were to write a matrix, let's say this is in comments, I'm just doing this so I can show you, you know, 7, 8, 9. Like this matrix that I just wrote here, I'll delete these for now. This is a 3 by 3 matrix that I have here. It is 3 rows, 1, 2, 3. Rows are going down, and 3 columns, 1, 2, 3. So this is a 3 by 3 matrix above. So we did a little discussion about how we add matrices, subtract them, and how we multiply them. And the next question is, how do we convert what we learned on the whiteboard and use it in MATLAB? So the first thing is how to write a matrix in MATLAB. I might change the colors to make sure you guys can see it okay. Give me a second. Oh, that's weird. Give me a sec. Where would this be? Yes. Sure. Okay. So the way that we write matrices in MATLAB, we write matrices using brackets, kind of similar to how you would in real life if you drew the brackets, these things. So if I wanted to make a matrix that is just one row, maybe I'll call it A. I'll do a bracket, and then I will write the elements in that matrix. So maybe 1 space 2 space 3, close brackets. So if I were to run this, you can see that I have a matrix A that is 1 row by 3 columns, so a 1 by 3 matrix. Now I can do this another way. I can do a matrix that is, 4, 5, 6, 7, 10, or something like that. Whatever. If I run that, you can see that now I have a matrix that is 5 columns with 5 different elements in it. For a matrix with more than 1 row, we use a semicolon. We'll tell MATLAB to go to the next row. So what I mean by that is, let's say I wanted to write this matrix up here, this 1, 2, 3, that's 1 row, jump to the next row, 4, 5, 6, jump to the next row, 7, 8, 9. I'll move that down here so we can see it. If we wanted to do that, maybe what I'll do is I'll write 1, 2, 3. I'll write a semicolon. Because MATLAB sees a semicolon, that means that you are done with that row, and then you're going to the next row. 4, 5, 6, semicolon, 7, 8, 9. And since we're done, we don't need to put another semicolon here because that would mean we're starting a new row. We don't do that. We just close it. Let me clear this. Oops. Make this a little bit easier to see. So now if I run this, you can see that we have a matrix that's similar to this, where you have 3 rows and 3 columns. It's going to be really important, really useful. So, we can do that in a bunch of different ways. Maybe I do 3, colon, semicolon, 5, 12, -2 or something. I want you to take a guess at what the size of this matrix would be. You can pause if you want to think about it, and then we'll come back. I'm going to assume you paused and thought about it. So the general idea is that I wrote an element in this matrix, and then I immediately go to the next row. 1 element, next row, 1 element, next row. So it's going to have 4 rows and one column because each row only has one number. So if I were to run this, you can see that I have a matrix that is 4 rows with one column. This is a 4x1 matrix. A command in MATLAB that's really useful command in MATLAB is the size command, which tells us the dimensions of a matrix. And again, the convention is row by column, RC. So if I were to do size of a matrix, let's say do size of D, which is the one I just wrote, I should get 4x1. This is rows, this is columns. If you look on the workspace, I have all these other matrices defined. So if we come back to C, we see that C is 3x3. If I do size of C, I get 3x3. What is A? A is 1 row, 3 columns. If I do size of A, 1 row, 3 columns. What was B? That's 1 row, 5 columns. So the size is very useful in order to know how many rows and columns a matrix is. Just to recap, we write matrices using brackets. If we want to go to a new row, we use the semicolon. If we're interested in knowing the size, we can go ahead and do the size command. So type size, parentheses, find the size of A. Put that there. Okay. The next thing is, what if we wanted to pick out a certain element in a matrix? Let's clear everything in the workspace. Maybe I'll say that A is equal to 1, 4, 5, 6, 10, -3. I don't know. So the size of this, based on this, it looks like we have a row that is 2 elements. So 1, 4. We jump to the next row, 5, 6. We jump to the next row, 10, -3. So if we were to run that, we can see that A is this non-square matrix that is 3 rows by 2 columns. So we can confirm that by typing size of A. So 3 rows, 2 columns. The question then is, how do we pick out a certain element in the matrix? Let's write A again. So this is the matrix A. If I wanted to pick out the number 5, for example, I wanted to assign that to a variable or use it in some mathematical equation. This number is in the second row, second row, first column. So the indices of that. So the number 5 in this example is in row 2, column 1, right? That would be kind of like A 2, 1 in our, if we wrote on the board with subscripts, it'd be A 2, 1. If we wanted to pick that out, all we would have to do is write the variable or the matrix letter or variable name. We'll use parentheses in this case, and we'll do 2, 1. We'll say that this is, I don't know, our answer. If we run that, it goes and picks out the element. So we use brackets for matrices, and we use parentheses to pick out certain elements in a matrix. Let's try another one. So if we were to go ahead, maybe we'll come back up to B and run, not B, come back up to C and run this C matrix. If I wanted to pick out the 6, here, that is in row 2, column 3. I can just do C, row 2, column 3, and that'll tell me that the number there is the one that I'm interested in, that's a 6. We do another one. If we do C of 2, 2, what do you think that's going to be? Well, second row, second column. So second row is this row. Second column is that, 5. If I were to do something that does not make sense, this is a 3x3 matrix, and let's say I tell it, give me the element of the 4th row and the 5th column or something, it's going to give me an error because of the fact that those spaces don't exist. It says must not exceed 3 because of the fact that this matrix is 3x3. And really, it says position 1, because as soon as it sees the 4, it's going to get mad. So if I do 3 and then 5, now it says index in position 2 exceeds the bounds because of the fact that the number of columns cannot exceed 3. So you can see that MATLAB is pretty good at knowing that you have an error because of the fact that we've already predefined the size of the matrix. It's 3 by 3. If you attempt to do something else, it will get mad at you. So that's a really, really useful exercise. So we type a row column to pick a specific element. I'll just do like a quick example, I guess. We'll say that A is 1, 2, 3, 4. B is, I don't know, -1, 4, 17, and 9. I don't know, I'm just making up numbers. Let's comment this out. So if we run this, we'll clear everything first. If we run this, we see that A will be, the first row of A is 1, 2. Then we jump to the next row, which is 3, 4. This can be a 2 by 2. And this will also be a 2 by 2. Doesn't necessarily have to be for what I'm going to do, but if we do that, we see that A and B are both 2 by 2s. What if I wanted to add the second element in the first row together? So maybe what I'll do is I will say, my answer is A. I want to add 2 to 4. That will be row 1, column 2. And I can add B, row 1, column 2. And if I do that, we should have 2 plus 4, and that should give us 6. So if we run this now, we get 6 because of the fact that it's calling out this number, it's calling out this number, and we add them together, and then we end up with an answer of 6. While we're on the topic of adding matrices together, we've learned in class that if they're the same size, we can add them together. So if I wanted to do A plus B, I'll write A and B. If we add these together, it will add the corresponding elements. So 1 plus -1, that should give us 0. 2 plus 4 is 6. 3 plus 17 is 20. 4 plus 9 is 13. So if I were to run this, you end up with the sum of those matrices being 0, 6, 20, and 13 because of the fact that we're adding the first element with each other, second elements with each other, third elements with each other, and the fourth elements with each other. Okay, really cool. So another concept that might be important, what if you want to extract a full row or column? So let's come back up and we'll pick the C matrix again. That was a 3 by 3. Let's clear everything on this again. And there's the C matrix. What if, for instance, if you think of an example where we say, like I think we talked about the students' grades in class. What if the students for test 1, this was the average of their grades or something like that, and you wanted to use this. We'll ignore any math, but let's say you just wanted to extract it out of the matrix. So to pull more than one element from the matrix, we're going to use a new command, colon, to help. So the colon, not a semicolon, is the double dots. And the way the colon works is that if you have it typed in a particular place, whether it's in the row or in the column, that's going to tell MATLAB you want every element in that row or in that column. So for example, and a way you can think about this, I guess, is like you see these dots here. Imagine there's like dot, 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 dot. It's just telling you everything that you want. Let's say I do C:1. This says to take every row in general, because of the fact that this is saying take every row, remember RC, every row, in the first column. So really, I guess a better way to say this is this has to take the elements in every row and in the first column. That's a better way of thinking about it. So if we see this colon, that's telling us to extract everything in a row. So that is, these are all the rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the rows. But it only wants it in the first column. So it'd be 1, 4, 7. And if we run that, we see that we actually pull out those elements there, 1, 4, and 7. Come back to C. Let's do another example. So we do C. The colon is every row and then the third column. So again, because this is in the R position, that is telling us to do every row. It'll be 3, 6, 9 in the third column. I'll suppress that. If we run this, we get 3, 6, 9. What if we want to do columns? Well, it'd be the same thing, but it'd be flipped. Maybe I say this. So this says, look at the second row. That's what the 2 is. And take every column. If we look at the second row, that's this row. And it's saying to take every column. Let's go ahead and run that. And we can see that every column in that row is 4, 5, and 6. Right? 4 is in the second row, it's in the first column. 5 is in the second row, it's in the next column. 6 is in the second row, it's in the third column. So this is saying in the second row, take an element from every column. Take an element from every column. Let's do another matrix. Let's make it more complicated, maybe. 1, 2, 3, 4, 5, 6, 7, 8. So if we run this, it's gonna be mad at me because I don't have C defined. So let's just do a new section. So we can see now that I have an array or a matrix that is 4 rows by 2 columns. Size of A is 4 rows by 2 columns. And I tell you, I care about 5 and 6. So ask yourself, if I needed to write something, here, because I want every element, I need to use the colon somewhere. But I want you to try to tell me what you think that somewhere is. So let's try to figure that out. 5 and 6 are both in the third row. We don't need to look at every row because of the fact we're only interested in the third row. So I'll type a 3 there. Because I want both 5 and 6, I can do a colon to tell me to do every element or every column in that third row. So now if I run this, let's suppress this so we don't see it again. We get 5 and 6. Okay, let's do another one. Let's say we do A of, say I do that. Not that. Let's say I do that. Now tell me, what do you think if I write A and I'm looking for the colon and the number 2 afterwards? What do you think? So this is saying to look at every row. And this is saying to look at the second column. So every row means we're going to look at every row, but we're only interested in the elements in the second column. That's going to be 2, 4, 6, and 8. So if we run that, we see that we extract 2, 4, 6, and 8 based on this command. Now we could continue to do this thing, but what if we want to be very specific and extract not just all the rows, maybe just a few of them. So let's be more specific. I'll write a bigger matrix here. Let's say the matrix is F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if I do that, we can see that we have the first row has 4 elements. Second row has 4 elements. Third row, fourth row. It's going to be 4 rows by 4 columns. So if I run this, we can see that we have 4 rows and 4 columns. We can confirm that by doing size of F. 4 rows, 4 columns. Let's pull F up. And the question then becomes, what if I want not just, every row in the first column or, every column in the second row type of thing? What if I want to be more specific? So let's say that I want these 8 elements there. So to describe that, that will be rows 1 and 2, rows 1 and 2, every column. Right? Because of the fact that I am extracting every column, 1, 2, 3, 4, those are the 4 columns, but I only want these 2 rows. So what I can do is I can tell MATLAB, if I just wanted the first row, I would do something like this, right? First row, every column. If I run that, you'll see, oops, suppress that. This one once. Do it in a second. There's that. If we do the first row, every column, we get 1, 2, 3, 4. If I wanted this, what I can do is I can tell MATLAB, I specifically want row 1 column, or row 1 and row 2 every column. So this is something you're just gonna have to get used to, is that sometimes when we group numbers, we'll use brackets to do so, kind of similar to how we group numbers in an array or in a matrix. So what this is saying now is that it's going to look at rows 1 and 2 and extract every column. So if you do that, you have 1, 2, 3, 4, and then the second row is 5, 6, 7, 8. And there's loads of different computations you can do with this. So let's comment that out. Let's do F. Maybe I'll do 1, 3 in every column. So what do you think that output's going to be? Well, this is saying, first off, every column. So that means that we would go 1, 2, 3, 4. It's just a matter of which rows we're going to pick. This is saying to pick rows 1 and 3. So row 1 will be 1, 2, 3, 4. Row 3 will be 9, 10, 11, 12. And we're doing every column. If I run that, we end up extracting the first and the third row into a new answer or a new matrix. It is a new matrix, because let's say I say that I call this a new matrix. That. See, here's our new matrix. If I take the size of that, that's 2 rows by 4 columns. So if you extract the matrix from a bigger matrix, that just gives you a smaller matrix with different dimensions. Let's say we do something else. Let's say we do F of excuse me. So pull up F again. Oops. There's F. I now have the colon in the row position. So that means we're going to look at every row. But the elements we're going to take are from these specific columns. So column 1 and column 4. So column 1 is 1, 5, 9, 13. That's every row. Column 4 is 4, 8, 12, 16. So if I were to run this, we end up getting first row, or sorry, the first column every row. 4, 8, 12, 16 is the fourth column every row. Columns 1 and 4. I can do the same thing with more than 2. I can do 1, 3, 4 if I want. Should clear it. So this is saying every row, and I want the first, third, and fourth column. So first column is 1, 5, 9, 13, 3, 7, 11, 4, 8, 12, etc. So if I go ahead and I run that, we end up extracting every element except the second one. If I were to do 1, 2, 3, 4, that would just give me the entire matrix again. What do you think that's equivalent to if I didn't want to take numbers? Well, if you've had a second to pause and think about it, if I were to take that, that is telling MATLAB every row, every column. So if you were to write F, now we're to say this is, I don't know, a new matrix. A new matrix will just end up being equal to F because of the fact that we're extracting every element in every column from F. And I have a bunch of examples in the notes, and let's go through these examples real quick. So I have a matrix. This is example number 5 in the note set. And we'll do this in class together, but I'm going to do it now. 1, 2, 3, 4. I'm just writing down the 9, 10, 11, 12, 13, 14, 15, 16, and then 17, 18, 19, 20. We run that. We see that this matches on page 18 of the note set, the matrix T that I introduced. And I'm just going to write down, the examples that I have here, and we'll try to go through it. So the first thing is saying T 3, 3. So this is saying to look at row 3 and column 3. That's a very specific coordinate. So this is a specific coordinate, for an element. So if I go to row 3 and column 3, I should get 11. So if I run that, I get 11. Okay. This is equal to 11. The next one is 5, 1. It's again a specific coordinate. If we look at row 5, column 1, 1, 2, 3, 4, 5. Column 1 is 17. So that means if we run this, we should get 17. That's equal to 17. Okay. I do T of 4 with a colon. Now this is saying we want more than one specific element because we're using the colon. Let's pull up T again. My dog. Let's pull up T again. This is saying in the 4th row, I want every column. So in the 4th row, 1, 2, 3, 4, I want every column. So 4th row, every column. So if we run that, let's suppress that. And if we run this, we end up extracting the 4th row. So this was 13, 14, 15, 16. Okay. The next one was T of 3, 1, 2. So take a sec to think about this while I open the door for my dog. So this says, remember, again, RC cars. Engrave that in your brain. Row 3, columns 1 and 2. Row 3, this is the 3rd row, columns 1 and 2. Row 3, columns 1 and 2. This will be row 3, columns 1 and 2, 9 and 10. See that? Row 3, columns 1 and 2. 1, 2, 3. This is row 3, columns 1 and 2. Okay, what's the next one? I don't remember if we talked about this yet, but this applies to both. You could do specific rows and columns both at the same time. So this says rows 3 and 4, columns 3 and 4. Rows 3 and 4, columns 3 and 4. So if you go to rows 3 and 4, and then you're going narrower, you're going to a more specific subset of this, Then you want columns 3 and 4, which will be 11, 12, 15, 16. Rows 3 and 4, so we're in here. Everything else can be ignored. Then we're going to look at columns 3 and 4. 1, 2, 3, 4. That means we're going to have 11, 12, 15, 16. So if we run that, you end up extracting 11, 12, 15, 16. And the last one we already kind of talked about, this is saying to pull every row and every column from the T matrix. So that is going to end up just being equal to the original T matrix. So if I run that, hope I didn't suppress this, suppress. If I run that, I just get the original matrix. Pretty cool. So let's just talk about some common errors real quick. So a possible error is that you do a bad job of writing your matrix. Maybe write 1, 2, 3. Let's say I write that. This is saying that my first row is going to be elements 1 and 2. So it has 2 columns. And my second row just has 1 element. You have like this weird L-shaped thing. Let's look at the error here. All matrix rows must be the same length. Look like details. We see there may be 2 rows of different lengths in this matrix initialization because of the fact that I don't have another element here. So if I try to run this, it's going to be mad because of the fact that the matrix needs to have the same size throughout it. So to fix that, I would add another row or another column, and then we'd be okay. So originally I wrote it without this 4. So if you ignore that 4, I wrote 1, 2, go to the next row, 3. And I left the spot empty. It does not mean that it's 0. It means that there's nothing there, and that's a problem. Because of the fact that the matrix needs to have, in each row, the number of elements needs to be the same. And we already discussed if I try to access an element that isn't present. So this is saying go to row 3, column 1. If I run that, it says you can't do it because of the fact that this is 2 by 2, and I'm asking to go to row 3, column 1. So again, we'll just put that out for now. If I had to do row 3, column 1, there is no row 3. That's going to give you an error. The other thing that people get confused about in MATLAB, especially if they've coded before, is that in MATLAB, matrix indices start at 1. Other programs may start at 0. So for example, if I run this and I try to do A of 0, 0, in another program, that would tell us to pick this value here. But in MATLAB, it starts at 1. Array indices must be positive integers or logical values. And I discussed this a little bit in the note set. Just be aware that that's how you can get errors. All right. Maybe I'll stop the video here and do a second video so that people can break it up. We're going to do that. Where is it? Okay. I'll see you shortly. In theory, when I stop recording. There it is. I'll see you in a sec.